Hello, dear learner. Welcome to this session on inverter operation and maintenance. In this session, we will see how a home inverter can be maintained with simple steps by opening the inverter and its internal circuitry, and then we will see how to do the troubleshooting and then some simple steps of maintenance of such inverters in case of some malfunctioning or not working condition of the inverter.
Let us begin. An inverter is a kind of equipment which has got an enclosure inside which the components are placed. The front side of an inverter usually consists of the alarm circuit and the switch, and the back side has got the connecting wires and the sockets placed. As we can see here, this inverter housing can be opened usually with the screwdriver. We are opening this inverter with a screwdriver, and then we see the components inside. This inverter has got a transformer and a converter, and this is a fan which keeps the inside of the inverter cool. The hot air can go outside through that fan. This is a socket which is used to connect the circuits of the household connections whenever power supply is not there. It has got three terminals: live, neutral and earthing. This is the live terminal usually, and we can see there is a fuse in this inverter, and this fuse is used to protect the inverter circuit from short circuit conditions. Whenever short circuit happens, this fuse is blown. There is a wire inside. As we open it, we can see a fuse wire is there inside this enclosure, and this wire gets blown or snapped whenever the fuse protects the circuit from some potential harm from short circuit, etc. So this part of the fuse can be replaced from available fuse element from the market. Now this is the inside part of the inverter. This transformer is used to step up the voltage, which works in AC, and this transformer is supplied by this converter, which converts the DC voltage from battery into AC and provides the connection through these wires, this red and the black wires. And we can see this is the main circuit board of the inverter, and this red wire is connected to the positive terminal of the battery, and the black wire is connected to the negative terminal of the battery. And this particular board is having connections to the indicators, fan, etc., and there are several electronic circuit components which are placed on the board. This is another type of fuse which is used to protect the circuit, the transformer. Basically, whenever the main power supply is connected and some short circuit happens, it will protect. Now this is the front side of the inverter where the indicators are placed. This is an indicator which shows main power supply is available. This is a battery indicator. When the battery is charging, that glows, and this is a battery overloading indicator. When the battery is overloaded and more number of equipment are connected, it is shown. These are other indicators which show battery connections from the UPS to the battery, basically the inverter. If this is an indicator for the low battery, and whenever there is the supply from the inverter in presence of main power supply is there, then this economy mode is on. So this is the main charging indicator of the battery, as we have understood. And this is the power switch. By switching it on, by pressing it, we can switch on and off the inverter, and accordingly these indicators will show the switching on or off condition of the inverter circuit. So this is the overall circuit of an inverter of a particular type. And when we open the inverter and try to check the components inside one by one, then we will be using a multimeter like this. Now currently this multimeter is measuring the DC voltage of the battery. It is connected to the battery terminals, and as we can see, currently the inverter is being charged and the power supply is on. So main power supply, and in presence of the main power supply, the battery voltage is shown to be 12.09. So when the main power supply is switched off, then also if the circuit connected outside like this bulb glows, that means the inverter is working. As we can see, the fan is also running and it is cooling it. So we can change the type of load and check the inverter whether it is able to supply the kind of load connected to the inverter properly or not. Now at this point we can see the light is being supplied by the inverter, and the inverter, now the main power connection to the inverter is disconnected, so this bulb is glowing because of the battery supplying the power to the outside circuit, that is to that bulb. And in presence of main power supply, it will show some voltage of around 12 or more. So that means the battery is working fine. So this is how we check the inverter's proper functioning. And this part of the circuit we will now see where the circuit board connections are there, and we will see the circuit board connections one by one. But before checking, we need to disconnect the power supply including the battery terminal, otherwise there is always a chance of electric shock. Now this is the main part of the inverter circuit. We have a converter there which converts DC into AC, and as we can see the different parts of the circuit board, there are several connectors and the wires which are connected to it. We will see all those connections one by one now. This particular connection is going to the fan. So fan is being supplied through the circuit board. This other connections, this particular connection as we have opened is actually connected to the switch that is present in the back side of the inverter. So that switch is used to step up or down the voltage level. That can be done. It is available in certain types of inverters. In some inverters it may not be there. The other connection that we see is this connection, which is going to the front of the inverter, to the indicators and the switch. And this particular one is for the fan, as I had already mentioned. The cooling fan connection is from here. This other connection is actually having the red connection, the black connection and the yellow connection, which are the connections from the main power supply to this particular board, which is used for indications, basically to indicate whether the voltage levels etc. are correct or not. This is another connection which is also used for alarm purpose. So there are indications and alarms which are generated when the power supply is not of proper level. This one connection that we see is from this particular terminal where the supply is being provided to the transformer. So all these connections into the circuit board are controlled by these different circuits, these circuit components. We have a lot of different types of diodes as well as the ICs. The diodes can be checked using a multimeter by setting the multimeter to diode connection mode, and then when we connect the two terminals of the multimeter to across these diodes and the circuit resistors, it will show the values. If the values are within limit, then they are working fine. If the values are beyond limit, that means these components need replacement. So such kind of replacement requirements are set by making connections from the multimeter to the circuit components. This is another IC, which is an important IC of the circuit board, and if this kind of an IC is found to be faulty and they do not show the proper values, or they are found to be faulty, they can be replaced by removing and replacing, and after that doing the soldering. So this is about the circuit board that is used for all the electronic activities of the inverter. However, this kind of replacement requires professional help, and very often if the circuit board doesn't work properly, then we may need to seek help from the manufacturer. Now, as we can see, this particular board has been fixed, and the voltage that we have been able to monitor from the battery is checked, and when we switch on the main power supply or switch it off, in both the cases the voltages of the battery are shown to be all right. And in this particular mode, now we see the supply is being provided by the battery, through the battery to the outside load circuitry, and this bulb is glowing because of the power supply that is provided by the inverter. So in presence of main power supply and in absence of main power supply, in both cases we should get a voltage that is close to 12 or slightly above 12 to be in correct condition. So at the moment this inverter is working fine. So this is how we will do troubleshooting, as well as we will check the healthiness of the inverter and whether it is working fine or whether it requires minor repairing. That can be determined by going through these simple steps. So that's all from the demo video point of view. Thank you.
Hello dear learners, we are into the second part of inverter operation and maintenance video. So in this part also we will discuss about inverter maintenance as well as repairing steps. We are taking another example of an inverter. In this particular inverter, it is simpler in design, but we have some problems in the circuit components, and these circuit components are basically the capacitor and the temperature measuring device, that is a thermostat. In many inverters, a thermostat is used to measure the temperature level of the inverter's inside enclosure. And there, that is why a fan is used in an inverter to keep the inside part of the inverter cool. Now, this cooling is a very important requirement, without which the inverter components quickly become heated up, and that may damage the internal circuitry very easily. So therefore, to avoid such kind of damage in the inverter circuitry, we must have the thermostat in proper condition. As we can see in this video, we have a thermostat placed here. Here, this is the thermostat, and this thermostat is responsible for measuring the temperature level of the inside enclosure of the inverter. Now, this thermostat, if not in working condition, the heat that is generated inside the inverter enclosure will not be properly monitored, and the fan will not be automatically switched on. So therefore, we may need to do replacement of the thermostat if it is not working correctly. Also, we very often deal with inverters where the capacitor, the number of capacitors inside the inverter is not working. In such cases, we may need to go for replacement of the capacitors as well. Now, replacing the capacitors or thermostat are not very simple task because these capacitors as well as the thermostat are connected in the circuit board of the inverter. So this circuit board needs to be dealt with using a soldering iron, soldering rod, and very carefully desoldering of the damaged component and resoldering of the new replacement have to be done. So for that we need to use the standard soldering tools, and then we must do the replacement of the faulty component. Here we can see from the back side of the circuit board that the connections to several components are made using the printed circuit board. We have to identify the particular type of component that we want to replace. Like here we are able to identify the thermostat that is not working currently, and in this video it will be shown how the thermostat can be removed first. The damaged thermostat will be removed first, and after that a new thermostat will be soldered into the circuit board. We can see the thermostat connection is present here, and this part we want to desolder. So we need to heat up the soldering iron, the soldering rod, and then we will have to take out uh, the connection from this circuit board for the thermostat. So we can see it is being prepared currently to desolder the thermostat, and while the desoldering is done, we have to be careful not to affect the nearby components because all different electronic components in the circuit are connected in this backside of the circuit board, and the overheating of the soldering iron may lead to damage of the other working components, other healthy components in the circuit board. Here we can see the soldering rod is being used to desolder the thermostat that is not working currently, and that thermostat is going to be removed. So this thermostat removal is a careful process that has to be done with an expert hand. Otherwise, overheating of the circuit board may damage the components in the inverter circuit. So here the desoldering is being done, by which the thermostat will be detached from the circuit board. So this detachment of the component will allow us to remove the faulty component, whether it is a capacitor or a thermostat, and after that we will be able to replace that faulty component by a new one. And these components are easily available in the market. While replacing the component, we have to see the specification of the component is kept the same. So new replacement and the earlier component must have the same rating and preferably made by the same company or vendor. So that will let the inverter run in normal condition like an original one whenever such replacement is done. So here new thermostat is being connected using some new wiring. So this new thermostat connection will lead to the repairing of the heat monitoring or measuring circuitry of the inverter. So in the same way, the capacitors or other such simple components of an inverter circuit board can also be replaced whenever there is some damage that is observed. And this replacement usually is to be done by people who are expert in doing soldering and dealing with electronic components. As we can see now from the front side of the inverter, the replacement of that thermostat, this is the thermostat. So this new thermostat is being done and it is going to be connected to these two wires. And if we want to check the circuit's proper operation, whether this inverter is working properly or not, then we can do so by switching on the circuit and also by seeing whether this inverter is working fine or not. The thermostat is some component which is used only to monitor the temperature and then to switch on the fan accordingly. So basically the fan connection or fan circuit is connected to this thermostat of the inverter. So when replacing the thermostat, before doing the replacement, we may check the working condition of the fan inside this inverter by shorting the terminals of the thermostat, by shorting the wires, two wires of the thermostat connection. So in this inverter, we are now going to check the working of the fan by connecting these two ends of the wire, and as we can see, when these two ends of the wire are connected together, the fan runs. So this way we are assured that the inverter's fan circuit is working fine. However, this inverter was not able to switch on the fan even when the components got heated up inside, because the thermostat was not working fine during the operation. So that is why the thermostat is going to be replaced now, and the new thermostat that has been brought will be connected. Similarly, the capacitors, as we can see here, may also be replaced whenever the capacitors do not work or they show some fault. And the same process is followed in case of capacitor replacement also, to desolder and do the soldering again from behind the circuit board. Now this thermostat is going to be connected to the terminals or the wires which are already soldered to the circuit board, and after that we will be able to check whether this inverter is working fine with the thermostat circuit and heat measurement circuit or not. So this soldering of the component with the wires also needs to be done carefully so that we do not have additional connections made while soldering between the terminals of the thermostat. Because these components are very small, so they also sometimes create problem while making the soldering, doing the soldering, because soldering sometimes leads to sorting of the terminals. So that also needs to be um, avoided, and we have to be careful while doing the soldering of such thermostat or other such components to the wires or terminals which are connected to the circuit board. Now this thermostat um, circuit IC is going to be soldered to the terminals, and after soldering the thermostat, it will be put into the inverter circuit, and then the inverter will be um, monitored for any heat generation that takes place in the inside part of the inverter enclosure. Now this thermostat will measure the temperature level, and if the temperature exceeds a particular level, then the fan will be running, and thus the inverter inside part will be kept cool, and then the circuit of the inverter as a whole will be within control. So this way the thermostat is soldered, and after soldering we can see that the thermostat is now able to do the proper work and the inverter is running fine. So this is all about the demo second part of inverter operation and maintenance, and in this part we have seen how simple circuit components can be replaced using soldering rods, and the simple electronic component testing can be done, and replacement of certain components from the components which are available in the market will lead to proper operation of the inverter when some simple components like capacitors and thermostats do not work properly. So these simple connections and replacements may lead to proper operation of a inverter, which can be done by any technician or electrical people who are proficient in doing soldering of the components in any electronic circuitry. So that's all for the inverter demo video and the operation and maintenance part of an inverter. Hope the learners will be able to now deal with simple inverter operation, maintenance, and repairing steps whenever it is required. Thank you.